And so that means that when it's involved is involved setting up some questions. So we do the testing to see whether we can answer those questions. And in doing so, we're judging the probability that an observed difference between groups is dependable one or happen by chance. So we talk more a little bit more about this hypothesis test about this point. Okay, so basically in inferential statistics, when you, for example, when you want to say whether these values and these value are different or not, there is no sort of like 100% different or 100% not different. Okay, it will be like, okay, there is that much chance that this thing is different from the other things. Maybe some obvious example of this is when you want to see whether some factor has the effect on the response. So hypothesis testing, you make up some null hypothesis and alternative hypothesis, and then you do the calculation, you get the p-values, and then you judging the probability whether the null hypothesis will happen at more chance. Okay, so inferential statistics is not maybe to you it's not a straightforward thing to explain, but if you understand about those idea, it will get you sort of like more sense when we actually do that, do those statistic experiment. Okay, now for inferential statistics, like I talked earlier, that it involves taking sample from populations. Okay, and in order to obtain samples from population, there were many methods to choose from. So next thing we are talking about is sampling method, how we take sample, okay, how we select the sample from the population. Maybe you have been samples of some sort of study before, right? For example, if you are walking around, people approach you and wants to ask you question or fill in the questionnaires, and that sort of stuff is the way to obtain population samples. Or recently, if you use Facebook, and if you use it like regularly, sometimes you get a choice, not really a choice, an option of doing survey about COVID-19 from University of Maryland. I think I've done it a few times already. So it's the way of the sampling that they want to get the data from about COVID-19 from people around the world. So they have some sampling methods to choose who's going to do the questionnaire. Okay, so there were so many sampling methods, and what I'm introduced to you is that is a different type of sampling method, and it is for you to judge if it comes to your study or to your research. Maybe not now, maybe in the future, I don't know. Maybe you have some sort of idea of how different they are and what is what you prefer to use. Okay, let us start from the below here. Okay, the first type of sampling method, okay, is the convenience sample. Maybe we see this all the time. Okay, so the sample, okay, are readily available. So it's the convenience sample is easy as to give example. If you are doing sort of like a senior project in some year, they do senior project and produce some edible product, okay, like fermented meat or some sort of food. And actually there were some consumer sort of like feedback, and the actual sampling method, if it is really a commercial product that you want to commercialize it, the way of taking those testers would be different, okay? But like for a study sake, most of the students would just ask their friend, okay, to give the test, okay, the sampling test. So that's a convenient sample. Or if you want to do some survey and then you are out and about in complex and just ask people who walk past and doing the questionnaire, that is a convenient sample. It is a sample that is readily available. Okay. Another sort of sampling, the way to get the sample is the voluntary response sample. Okay, so what happened here is the researcher requests member of a population, okay, maybe just asking people on the street and ask if they want to do the survey or to participate in the experiment, okay, and then people decided whether they want to involve in that experiment or that study or not. So that is voluntary based, okay? So this type of sample can be biased as well. Another sample is simple random sample. This one is very similar to convenience sample. Simple random sample is when every member of the population have equal chance of being selected. It would be more like for these two type of sample, the convenience sample and voluntary response sample is more like you have it there already and you are going to choose that. So there could be some bias in taking sample, but simple random sample is a little bit better where you have a set of sample and there is no bias in picking up a sample. Okay, and the next sampling method, okay, the next sampling method that is, to my opinion, it is better than these three methods, okay. One type is a stratified random sample. A stratified random sample is explained in this sort of like diagram. So you have like a population, and then the population split into groups, okay, and some member of each group, not one, maybe two members of the group or three members of the group, depending on the size of the group, are chosen at random. Okay, so in this picture, you see that the population is divided into two groups, and then the group of four, okay, and one of each group is picked out, become a sample of a study. Okay, another type of sampling is the cluster random sample. Again, you have population that is split into groups, okay, and in random, okay, in random. Then you pick the whole member of the group as a sample. So in this case, researcher pick this group, everyone in this group, the sample, okay, maybe another one. So like it could be that group, the second group, and or the third group that is picked as a sample, but everyone in the group become samples. Okay, unlike the stratified random sample where split into group and then representative or some member are chosen from each group and become samples. So it's the difference between the stratified and cluster random sample. And the last sampling method, okay, is a systematic random sample. That is when the member are put in some order. In some order means randomly. So it's not from high to low. Okay. It I'm sorry. The member are put into some order. Okay. And the starting point is selected randomly. Okay, and then from the starting point, you select, like in this case, you select every two person, okay, as the sample. So it could be in order, into some order means it could be by age, okay, it could be by height, it could be by weight, and you pick a start people, and then you pick every whatever you want. Okay, you could start at people number 1 and pick every 3 people, or you could start at number 3 and pick every 2. Okay, so that is systematic random sample. It's still random. Okay, it's still random, but it has some systematic work onto that how you get the random number. So I could give you some example from, say, a stratified random sample, for example. Okay. Say if you are doing some research, okay, about composting, and you want to take samples from the compost to analyze for maybe numbers of bacteria or type of bacteria that is in that in that compost. Okay, so the whole compost pile, which contains microorganism, of course, would be your population. Okay, so it's a population of the whole bacteria. So in this case, you don't pick the convenient sample. Okay, I'll pick this point and that's it. Okay, so it's like you have to probably imagine in your mind that how are you going to break down this pile, not physically, not like taking it apart. So it's the whole pile, and then you take one sample from this side, one sample from that side, how depth it is, or sample on top, and then you have your sample group, and then you do the analysis on that. Okay, for example. Or another thing is that for the cluster random sample, say you know, like for like supermarket, in supermarket, when they have to see the quality of the fresh stuff that comes in, right? So for example, if it's a cabbage, they want to see whether you pass the QC. Like the cabbage comes in like at the back of the truck. Okay, the cabbage come in at the back of the truck. So the cabbage could come in like a boxes, like 100 boxes in the truck. If you want to sampling whether it passed the QC, maybe you pick one box and then inspect that box and to see whether the rest of the box passes the QC. Okay, so it's so it can be used in many ways. Okay, it can be used in many ways. And what else I could think about taking sample? Oh, COVID is probably another easy samples that could be given example of. Okay, so the easiest thing that I could think of is the study where where they have vaccination. Okay. And after getting vaccine, whether you have more antibodies, okay, so choosing samples to have conclusion on that study has to be very careful too. If you have like a convenient sample, okay, okay, we are going to study people in faculty of technology. Okay, so that's convenient sample because you can take sample from people who knows already, but it might not represent what actually in the population by itself. So the study like this, okay, just like the phase 2 and phase 3 trial of the vaccine or the real life situation of the vaccine, the way they chose the sample is very important too. Okay, whether it has to cover the age group, the geographical things, or sex, or that type of stuff. So sampling method is important and is beyond what we are thinking of taking sample from the flask. Okay. Basically, taking sample from the flask is something else. Okay, is something else. It's partial sample from the whole flask population. So you can think that it could be a stratified random sample. It's very close to stratified random samples. Okay, because you take some from the group of the thing that you have already been done. So it's a sampling method that somehow you have to take into account of whether that study is believable. Okay, because somehow you could start with a very good plan of your experiment or of your research, but you chose the best sampling method and you conclude your study, and it could ruin the whole thing of your work. So sampling method is important. Okay. Oh, one thing that I need to mention here is whatever you do with statistics, do not have bias. Like sampling method don't have bias in getting sample. Okay, so that is important things. And one thing I normally give example is to give a population an equal chance of being selected as sample. For example, if you are fermenting or cultivating some of the microorganism in the in a flask, okay, and you know that you leave it as a static condition, somehow if you taking a long time for the experiment, sometimes your cell settle, right? Okay, believe it or not, some students do not stir it before they're taking sample. So that's bias sampling already. So to give equal chance of the population to be picked at random is you mix them, make it homogeneous, and then take sample. Because sometimes I get asked by students whether do I have to stir it before I take sample? I said yes. Give them an equal chance of being picked by you. Okay. Okay. The next thing from sampling method that I want to talk about is the probability distribution. I will talk in general and giving just sample for you to get the idea of how the probability, each type of probability distribution differ from others. But really what we use most are only a few of them, okay? So probability distribution is the way to describe how the value of a random variable is distributed. Okay, we talked about that a little bit already. whether it's a normal distribution, remember what when we talk about the skewness, okay, or whether it's a right skewness or it's a left skewness. So it's the shape of the population distribution. So probability distribution describe how value of a random variable is distributed over the whole population. And there were two main types of probability distribution, whether it's discrete or continuous. Okay, discrete, I'll just talk name first, and the next two slides, next 2 or 3 slides, we have some example. Okay. The discrete probability distribution include binomial distribution, Poisson distribution, continuous uniform distribution. Okay, for the continuous distribution, we have exponential and chi-square. Okay, there's no particular reason I put this thing up here, but what I want to mention is that for continuous distribution that we use most, okay, are F distribution. We involve with most are F distribution, T distribution, and normal distribution. Maybe normal distribution not as much as T or F distribution. Okay. Basically, for these two, the way we use is quite specific and could be different from studying of the population T and population F distribution, because we apply F distribution in finding whether the factor that we are interested has an effect on the response or not, and T distribution is to comparing two different values. Okay, this is for the sake of knowledge. Okay, I want you to know that the distribution could come in 1, 2, 3 in 8 type of distribution. We might not use all of them, but it is good to understand how they are used. Not really understand, to know how they are used. Okay, so all these type of distribution are discrete distribution. By being discrete means that there were a range of values, okay, that is not a graph, a continuous graph, but it's like a bar graph. So it's called a discrete distribution. Okay, so the graph look like this, like bar graph is a discrete distribution, and if it comes into curve like this, so it's continuous. So basically that is a difference between the two. Okay, the first distribution is for the discrete distribution is a binomial distribution. Okay, by definition, the distribution is a probability of getting X here, successful X time, success X time in an n independent trial, each of which has probability of P of success. Okay, look at this example. That would be easier. This type of distribution, okay, can be used in this case example. Okay, so the example is that if you have 12 multiple choice questions, so you have in exam you have 12 questions, okay, and it is multiple choice question. Each question has 5 possible answers. So each question 1 has A, B, C, D, E. Question 2 have A, B, C, D, E. So each question has 5 possible answers. And out of those answers, only 1 is correct. So whether it's A, B, there's no 2 that is correct at the same time. So the probability of being correct in each question is 1 to 5. Correct? So binomial distribution is used to find the probability of having 4 or less, of getting it right. Okay, if the student do all the question, what are the probability that they get 4 of the question correct in this one that I put in. So find the probability of having 4 or less correct answer if a student attempt to answer every question at random. Okay, at random means it's not all A, not all B, because you know, like some students when they have multiple choice question, okay, I should get 25% probability if I just get all A. Okay, so question 1 to 12 all A, question 1 to 12 all B. So it's not always the case, okay, because most of the time things are random already. So in order to see the probability of getting 4 marks or less is what? Okay, so that's how the binomial distribution comes into play. The second type of distribution is Poisson distribution. Poisson distribution says that it is the probability of obtaining X occurrence in an interval. This occurrence has the mean of what is that, lambda occurrence per interval. Looking at the same example, okay, this is statistic term, it's quite difficult somehow to understand anyway. Looking at the example, maybe you see the difference, okay? So they said, in average, there are 12 cars crossing a bridge per minute, okay? So the lambda here is 12, so it's 12 cars per minute, so it's 12 per minute, okay? In average, so that's the average. Find the probability of having 17 or more cars crossing the bridge in that 1 minute. So that means that at one point there probably be 2 cars, okay? One point there probably be 5 cars per minute. One point it could be 10 cars per minute. Some point it could be 30 cars per minute, okay? So finding the probability of having 17 or more, so from 17 car per minute to whatever car per minute above 17, what is the probability of that thing happen? Okay, so that sort of thing has to use Poisson distribution. Okay, we might not get this as in our work, but maybe if you need to come across this thing in the future, maybe you are thinking about this. And once you know the case example and how each of distribution could be used, then it is easier for you to find the actual example or actual explanation when you actually have to use it. Okay. Next one is the continuous uniform distribution. It's continuous uniform distribution doesn't mean that it is a continuous distribution, okay? Continuous uniform distribution is like on and off here. You see the graph here, right? It is a probability distribution of random number selection from the continuous interval between A and B. And the example is this. Okay. The average weight gained by a person over summer is uniformly distributed from 0 to 15. So people could gain weight from 0 to 15 kilogram. The continuous uniform distribution is used when you want to find the probability that a person will gain between 10 and 13 during the summer month. So that's how the uniform distribution works. Okay, so each example for each distribution is different. So you need to understand the situation before saying which distribution could be used. Okay, and for the continuous distribution, the first one that I want to talk about is the exponential distribution. Okay, looking at the graph, it's an exponential curve. Okay, and it is characterized by the mean rate, which describes the arrival time of randomly occur independent event sequence. Okay, looking at the example of what sort of situation that exponential distribution comes into play. Okay, if you go to supermarket, okay, and you have to wait at the cashier, and the study, okay, has collecting the data and say that, okay, the mean checkout time, the average checkout time of a supermarket cashier is 3 minutes. Okay, so each person has to wait 3 minutes to get into the cashier. Find the probability of a customer checking out being complete by cashier in less than 2 minutes. Okay, so this in this type of situation, use exponential distribution. For chi-square distribution, okay, now from chi-square, normal, F distribution and T distribution is what probably related to us more than what I have said earlier. Okay, so the chi-square distribution is the test of independence of two categorical variables, whether this variable is independent or depend on the other one. Okay, and you see that the distribution curve is the right skew distribution. Okay, and it gets sharper when the DOF is less. Okay, so less number of sample, the more peak it is. Okay, and in this one, it starts to have like a hypothesis that we are familiar with. Okay, so if the two variables are independent, so that is the main or new hypothesis, and if they are dependent, is the alternative hypothesis. And the example are like this. A random sample of 395 people was surveyed for their highest education level they obtained. Okay, and since it is categorical variable, okay, so of these 395 people, they categorize these people into two groups. Okay, the first group is gender, which is men, women, are not preferred. Okay, in this world now, there's a not preferred. So, and education level is category 2. So it could be high school finisher, a university, or postgrad. Okay, so the chi-square distribution is trying to say that whether the gender depends, whether the education level depends on gender. So like it's more like, is more male, is more men finishing higher level education than female. So that sort of stuff. So use chi-square distribution. So it's not individual sample, it's a categorical variable. Okay, and it's being tested at how many percent of significance level. The significance level stuff is what we are going to talk about next too. Normal distribution, okay, normal distribution is one thing that we have mentioned a little bit earlier about the shape of the distribution itself. Okay, it's a distribution of population mean. Population mean is mu. Okay, sample population is x bar. Okay, with the variance, a standard normal distribution is when mu is 0, and so that is a feature of normal distribution. And the case where we use normal distribution is as followed. Okay, if the test score of a final exam fit a normal distribution and the mean is 72, mean or the average is 72, and the standard deviation is 15.2. Okay, we want to find what is the percentage, how many percent of the student getting 84 marks or more in the exam. So that means that for the normal distribution, okay, if the test score fits the normal distribution with the mean of 72, which is in the middle here, 72, right? So the standard, so people who get less than 22 is normally distributed to the left-hand side, and the people who get more than 72 is normally distributed on the right-hand side. So what is the percentage of students scoring 84 or more? So 84 or more is probably somewhere around here. So see how many percent in that area under the curve, okay, that cut at 84 or more. Okay, so how many percent is in that area of the curve? So that's how that's how the normal distribution is used, because I mean, if data is normally distributed, you know that the middle is the mean, right? And then at one standard deviation, how many percent of people will fit in that standard deviation, and how many people fit into the two standard deviation. If you go back, I'm sorry, back quite a lot of, you see that the normal distribution is what we talked earlier. So in that case, so 72 is the mean values, okay, and one standard deviation, okay, plus and minus, you have 68% of the people within that range, and from that one plus 2 standard deviation and minus 2 standard deviation, you have 95% of people in that range. Okay, so that's how we could use standard normal distribution curve to calculate something like that. All right, so, and like I told you earlier, this is somehow in some of the subject where they do the grading based on group performance, they might use normal distribution as well. The point is that if the test score or the mark of the student doesn't fit normal standard deviation, it may not be a good way to grading students. Now comes to the two types of distribution that we probably use the most: student T distribution and F distribution. So that is when you do the T test and the F test, when you are dealing with statistical when you are dealing with the experiment, and then you do statistic to compare things, or to see whether a factor is actually affect the response. Okay, now looking at the T distribution, okay, the T distribution has the shape that we talked about earlier, and the more the degree of freedom, the higher the degree of freedom, it is closer to a normal distribution. But if you have less degree of freedom or less number of samples, then it's further away from being normal distributed, because the curve look very similar, right? But the normal distribution has some character in it. So the more DOF in T distribution, the closer it gets into a normal distribution. Okay. The T distribution is used for making decision to support or reject null hypothesis. Okay, using a small case of sample size less than 30, okay, or population is unknown. Normally, our population standard deviation is unknown because we only involve a small sample, so that's why we are using T distribution. Okay, samples might be from population with a normal distribution still. Okay, so this is a two-step assumption. That's what I'm saying. Most of the time that's why I'm saying that most of the time we have assumption that the population have a normal distribution. Okay, and for T distribution, the population is unknown. That's when you can use T distribution. Okay, the case example is this one. Okay, if we make an IQ test and the score of the IQ test are normally distributed with the population mean of 100, so that means that the average of people get IQ of 100 points. If 20 people are randomly selected and do IQ test, okay, while the population is it's normally distributed, so that means that mean of IQ of people 100 and only that much percent of people get IQ of that much, okay? Suppose 20 people are randomly selected and test, okay, and the standard deviation in the sample group is 15. That means that the standard deviation in the sample group is 15. What is the probability that the average test score in the sample group will be at most 110? So that's how that's what the T distribution works. Okay. However, we don't use T distribution in this manner. Okay. We normally use T distribution to compare the difference in mean values. Okay. We compare whether we have mean values from one condition of the experiment and another condition of experiment, and we want to see if these mean values are different. We're using T distribution to do the testing. Okay, but this is the general case where T distribution is used. Okay. Now, the last distribution I want to talk about is the F distribution. Okay, F distribution looks so much like chi-square distribution. I mean, if you are looking at the shape of the distribution curve alone. Okay, F distribution commonly used in ANOVA, analysis of variance. That is what the name ANOVA is. Okay, so F distribution commonly used in analysis of variance, and it compares variances of two independent samples. Okay, so they don't compare the mean, they don't compare something else, they compare the variance of the two independent samples. Okay, so when we are doing F distribution, they are normally involved 2 degrees of freedom. Okay, involving 2 degrees of freedom. If you have done some undergrad course on like experimental design and you have done F distribution to see F test to see whether a factor actually affect the responses, so you know that you have to have 2 degrees of freedom involving in one value of F. Okay, so that's how it goes with the F distribution. Okay, case example, this is very common. I mean most of the time you see it all the time, but maybe you haven't thought about it. It is the test to see if factor have any effect on responses. Okay, maybe if you want to test if sugar concentration affect the cell growth, or to see if you are doing modeling or you are doing response surface methodology to test if the model is sufficiently explain the experimental results. That's when you use F distribution to see whether something affects something. Okay. And like what I told earlier, that we most of the time use T distribution and F distribution. Okay. We actually go faster than what I thought. Okay, but that's okay. I'll just keep going then. Now, once we have talked about sampling, once we have talked about distribution, Okay, and you probably start to see that in continuous distribution is very so like close of what we have heard or what we have done. Like we start having seeing the comparison between stuff and what type of distribution is using in what case. Okay, next thing that I want to talk, which is the main part of the inferential statistic, is the testing the statical hypothesis. Okay, so in inferential statistics, it is asked to explain the population. If we go back to earlier slide, okay, so it's you take sample and then you do something and then you explain the population, like extending the results to the population. So in statistical hypothesis, okay, you probably remember that there were two types of hypotheses that we have to make. Whatever we want to prove, we want to say that it is true or it is false. Not really true or false, okay, but just making things easy for us to understand at the moment, okay. So when we are doing statistical tests for something, okay, for example, to see if the mean are different or if these factor affect the response that we are interested in, we have to make up hypothesis. Okay, and there's two types of hypothesis, a null hypothesis and an alternative hypothesis. Okay, there has to be two. I mean, alternative hypothesis is not when null hypothesis is wrong. Okay. Okay, so the null hypothesis is if you are seeing null hypothesis or alternative hypothesis, one thing that might come into mind if you want to see which one is null hypothesis or alternative hypothesis is the equal sign. Okay. Okay, it's an equal sign. It is null hypothesis. Okay. Some people, okay, about this word null. Okay. If you are British or Australian, is null. But you probably, if it is American English, is null. It's like data and data. Okay, so it's null hypothesis or null hypothesis. I'm more into null hypothesis rather than null hypothesis. Okay, so for null hypothesis, the statement always contains equal sign. Normally it contains equal sign. Okay, and if you are reminding yourself about F test, that equal sign is equal to 0. Okay, and the null hypothesis says that there is no relationship between two variables. So null hypothesis says nothing happened, basically. It is a statement that one wish to disprove or we want to reject. We don't want this to happen, okay? And the statement contains equal sign. So this is the point to spot, okay, or to notice null hypothesis. If it is null hypothesis, no relationship, we don't want it, and it contains equal sign. For alternative hypothesis, is the hypothesis that reject null hypothesis. Okay, so if you are using null hypothesis and you say that this is true or you accept that, the opposite is doesn't mean that it is wrong. Okay, so it is hypothesis that reject the null hypothesis. It is the statement that one wishes to prove. Okay, and it is the statement that contain unequal sign. When I say unequal sign, it can be the not equal or the more than sign or the less than sign. So as long as it's not an equal sign, it is alternative hypothesis. Okay. So if you want to prove that something has an effect, or if you want to prove that these two are equal, okay, it is always alternative hypothesis. So basically, if you want something to happen, you want to reject null hypothesis, basically. But the way the statistical work is like this. Now, a little bit more on hypothesis testing. Okay, we don't have much on hypothesis testing because it's sort of like more like a concept, and if it goes into too much detail, maybe it will take like a whole statistic course anyway. Okay, for hypothesis testing, the testing is done to see whether the claim or the hypothesis is valid. Okay, so like I told you earlier that we have two hypotheses, right? Null hypothesis and alternative hypothesis. So we want to say that something is valid by having those two hypotheses, and we want to disprove the null hypothesis. Okay, the test is the test for probability that rare event will occur. Okay, I focus on these two words. Okay, so it's a test for probability. When we say probability is not right or wrong, 100 and 0, or true or false, or black or white. Okay, it is the probability that something will happen at that much percentage. Okay, so it's the test for probability that rare event will occur. So whatever you want to prove, it is a rare event. Okay, for example, if you want to say that temperature has an effect on growth, okay, and you do the statistical work, you prove, you do the hypothesis testing, and if the result comes out that temperature has an effect on growth, that means that the rare event has already occurred. Okay. The testing is to test a claim by differentiate or distinguish between two different events. Okay, event easily occur by chance and event unlikely occur by chance, which is the rare event. Okay, this is the definition of rare event. Rare means I hope everyone knows what event is, right? Event is something that happened. Rare is ไม่ค่อยเกิด so rare means doesn't happen frequently. It's a small chance that it will happen. Okay, like the meteor hit the earth or something like that, that would be the rare event. Okay, when something happens, okay, it could happen because it is rare event that it happened, or it could happen by chance. By chance means by chance means it's random, it just happened. Okay, it is something that just happened. Okay, so it differentiates between whatever can happen. This is normal, this is happen, it just happened, or whether this one is a rare event. Okay, it's not likely to happen but it happened, so that is a rare event. That is the hypothesis testing. Is distinguished, is differentiate between these two type of event. Okay, so if rare event occurs, assumption of the null hypothesis was not true, so you reject null hypothesis. Okay, by rejecting null hypothesis doesn't mean that you accept alternative hypothesis immediately. It doesn't work like that. Okay, but most of the time we say that we reject null hypothesis and accept alternative hypothesis. It's different. Okay, rejecting null hypothesis doesn't mean that you accepting alternative hypothesis. Okay, and since it is test for the probability, that's why when we are doing statistical tests, we have to mention the confidence level or significance level of the test. Okay, since this is probability, okay, it's probable. So you want to know it is not like 100% happen or 0% happening. Okay, so the confidence level and the significant levels are related. So let's talk about the confidence level first. The confidence level is the expected percentage of time that the actual value will fall within the precision limit. That means, okay, that means that how many, more or less, how many percent this thing would happen. Okay, how confident are you that that thing is happen? So into translation, another word is significant level. Okay, significant level is the likelihood that the answer will fall outside the range. Okay, so the significant level is alpha. You will see that in most of the statistical, in all statistical work, when they are calculating something, they have to refer to alpha. Okay, either alpha or confidence level. Okay, and the common values for significant level are 0.10, 0.01, 0.05, and 0.1. That is the most common. And the most common is significant level of 0.05. So if you, it's also the default for the statistical program as well. If you use SPSS or if you use Design Expert, okay, when they are calculating the statistical term like F values, or they comparing and say that this thing is significant, this thing is not significant, that is within the significant level of alpha 0.05. And when I say it is related, that means that it is something like this. Like if you have the alpha of 0.05, that means that you have a confidence level of 95%. So more or less it's add up to 100%. Okay. So one way or another, if you see something says that, okay, this is maybe something like temperature has an effect on growth at 95% confidence level, you can say that, or you can say the same thing and say at the significant level of alpha equal to 0.05 is the same thing. Okay, and you'll see why in the next slide, which I think I'll leave it until tomorrow. Okay, now significant level and confidence level, there were some notes about it. Okay, actually, when we are doing statistical tests, there could involve some errors. Okay, it doesn't say that, it doesn't mean that what we are calculating and looking up the table, there's no errors involved into it. But it's not the errors like in descriptive statistics where it is the errors from the mean value, something like that. Is different things. Okay, so significant level is probably is a probability to commit type 1 errors. Okay, so type 1 error means you reject the null hypothesis when it is actually true. Okay, so that means that you conclude wrong. For example, if you calculate things, okay, and then you conclude that this factor has an effect on temperature has an effect on growth with a significant level of 0.05 or 5%. This significant level means that that is only 5% that you make the wrong conclusion. The wrong conclusion in this case means it's the 5% that you wrongly reject null hypothesis. So it is 5% that you could be wrong. That type of thing. Okay, so that is a significant level, and that's why it comes into play, because since it is statistic and it's not definite, it's not like 3 minus 2 equal to 1. So when you're calculating something based on the data that you have, and then you use inferential statistic to make a decision on something, of course it could be errors. Okay, even though you have already accounted for the number of repeats that you do, you still are committed to that errors. Okay, and that significant level tell you that you could have 5% of being wrong, 10% of being wrong, or 1% of being wrong. Okay, so this second point just elaborate the first point. So alpha, or significant level of 0.05 or 95% confidence level, means that 5% chance that we make type 1 error, reject null hypothesis when it shouldn't be rejected. Okay. Another term that you probably see is the p-values. You see a lot of p-values in when you read papers. Okay, p-values normally, okay, most of the time when you see p-values, I notice that a lot of students say, okay, p-value is less than 0.05, so this thing is significant, this thing is not significant, or whatever it is. P-value is the values that you have to use to compare with the alpha, okay, to see if we would accept or reject the null hypothesis. So if your p-value is less than alpha, you reject null hypothesis. You reject null hypothesis means that you reject that thing has an effect, and you imply that this thing, null hypothesis means that if you reject the null hypothesis, okay, go back to null hypothesis. You reject null hypothesis. Basically, you say that factor doesn't have an effect of the response. Okay, and if the p-values is less than alpha, and since most of the time alpha is 0.05, that's why you always say that if p-value is less than 0.05, this thing, I mean, the factor affect the response. That is when you reject null hypothesis. But if you do the test at alpha equal to 0.01 and your p-value is 0.03, you will have to accept the null hypothesis and say that the factor doesn't have an effect. So it actually depends on the significant level that you are doing your statistical test also. Okay. Okay, I think I'll leave today's lecture here. At this point, okay, at this point, I know that is very confusing, because like for me, this stuff you probably do it in statistics in your first year or second year in your bachelor degree. I did this time when I was in second year, so it can be it could be forgotten. Okay, but before we leave, okay, I just want to take any question in Thai or in English from you, and we wait a while, and if you don't, we could have a toilet break, and if when I come back in a few minutes, and if you have questions, just ask it now, or if you go back and then thinking of something, I could have like a Q&A section before we actually start the rest of the lecture. Okay, maybe you take a few minutes break, and then I'll come back and and uh and see how things goes. Okay. Okay. Okay, I think I take any question. If you have some concern of not understanding at all what it is or how it is different from different between descriptive and inferential statistics, you are welcome to ask any question. Okay, because I know that it could be very difficult if you don't remind at all about statistics like background. Okay, but yeah, so I want to see if you have any question. Any question is fine. I mean, any. You don't understand why this thing is work for that one or blah 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 blah. Okay. Okay. All right. If not at the moment, like I told you earlier that I could take like any question or something that you want me to explain early before at the beginning of the lecture tomorrow morning. Okay. So for today, if no one has any question, we could dismiss the class and I'll see you tomorrow morning. Or if anyone want to hang around, just in case you have any question, just, yeah, please do it. Okay, if not, you can leave the room. That's okay.
ขอบคุณครับอาจารย์
ค่ะ โอเคค่ะ ค่ะ สวัสดีค่ะ